Unit 6, Section 2, Video 2, all about similarity. Here we're going to work through a couple examples regarding what it means for polygons to be similar. So example number 2 is if triangle ABC is similar to JKL, write congruency statements for the angles and proportions for the sides. So note that I can only do congruent statements for the angles, and then I have to do proportions for the sides. I can't say that the sides are congruent because I only know that these triangles are similar. So these work very similarly to congruency statements of knowing that those angles, the letters, are what matches up. So for angle A, I know that angle A is equal to angle J because they're both the first letters in each of them. I know that angle B equals angle K, and I know that angle C equals angle L. And when I think about proportions for the sides, I'm going to write myself a key so I'm consistent. So I'm going to do triangle ABC on the top, and then I'm going to do triangle JKL on the bottom. And once again, I line up the letters to say that side length AB over side length JK should be equal to side length BC over KL, because those are second and third letters. And then I also know that side length AC over JL, they should all equal the same scale factor. Here in this next example, we're given a picture of two polygons, and we're told to write a similarity statement. And we know that they're similar because we can see all of those angle measures line up to be equal, and that those fractions, and we can double check to make sure that they are proportional, but it looks like they will be. So our similarity statement would essentially be to say that polygon ABCD is similar to polygon, I'm going to start up in the same corner with EFGH. And once again, I can check that because I know C and G are the same, so they are both the third letter and they should line up as I have. And if I want to check the proportions to make sure that they are actually similar and to find my scale factor, I can set those up. So I'm going to do the bigger one on the left over the smaller one on the right. So I'm going to do 5 over 2.5, and that should be equal to 6 over 3, which should be equal to 7 over 3.5, which should be equal to 4 over 2. And if I simplify all those down, I get that those all equal 2 over 1. So that means my scale factor is 2. And if I had written it so that the smaller one, the smaller measurements were on the top, I could have gotten my scale factor is 1/2. So 1 over 2. It just depends on which way I'm going and which way I write it. So it depends on which one you're talking about as the original and which way you're going. Example number 4 asks us, are these quadrilaterals similar? Why or why not? So if I look at these two polygons, I initially see that those angle measures are definitely not equal. I see that all 4 of these are 90 degrees and none of these are 90 degrees. So I know that those polygons are not similar because angles are not equal. If I look at the next example, are these quadrilaterals similar? Why or why not? Well, I do see that they are all 90 degrees, so all the angles are equal. That's a good start, but now I need to check to see if the side lengths are proportional. And this one's a little more obvious that they're probably not going to be, because I think about setting up 5 over 3 over should equal 3 over 3. And then I could keep going around for, 5 over 3 once again should equal 3 over 3. Those should all be the same. but those are, in fact, not equal. So it's not similar. Because sides are not proportionate. Because if I simplified that down, I could get 5 over 3 equal to 1, and we know that that is not true. So that's why we know that those are not similar. And the next video will have some more examples yet.